Uh, okay, so there's, there's more than you can do with audio. Just hit play. This tutorial will cover some of the basics audio programming, recording, and playback. Also, make sure you're using the latest version of STL. To understand how audio recording works, it helps to understand how audio data work. Okay, this is the sound. Now let's zoom in on it. As you can see, sound is a wave. A wave can be represented by a sequence of values, or in the case of the stereo sound, two sequences with one for each sound wave. Okay. Playing audio is just sending a sequence of values to the audio driver, and recording audio is copying a sequence of values from the audio driver. Okay, so I'll create sound. I think I should create this new file sound.h and sound.c, right? And then I want to open everything in sound. Okay. So if we need strings and sound texture timer window cam, I won't really need. Let's save this workspace. Yeah. Audio recording. Okay. So maximum number of supported recording devices. I think. Okay, recording state. Okay, this is maximum recording time plus padding. Okay, so maximum number of recording devices. Okay, so I'll define sound h, then to define sound h and end of. Okay, then I want to include stl2 stl dot h and stl2 dash stl mixer dot h. Okay, no, I don't want to buy it. Okay, right. Okay, I hope I have done it right. stl underscore image, stl underscore tdf, and stl underscore mixer, right? Okay, then we go maximum number of supported recording devices. Okay, so we'll go on. Also define this maximum number of supported recording devices. I go max recording devices. Max recording devices equals 10. Then we have maximum recording time. Okay, I'll declare these two variables. Okay, let's declare it here. Maximum recording time, constant max recording seconds, constant max recording seconds equals 5. Then we have then we have maximum recording time plus padding. Okay. I go with maximum recording time plus padding constant max buffer second. Okay, max recording seconds, then we have recording buffer second. Recording buffer seconds equals 6, which is whatever the max recording seconds plus 1. Okay. Then the various recording actions we can take, right? Then we have various recording actions we can take. So we create a global enum of selecting device, and we have stopped recording, recorded, stopped recording and recorded. Then we have playback and error, okay. Then here are a couple constants we'll be using. First, there's a constant defining that will only support up to 10 recording devices to choose from. We only need one for this program to work. Then we have maximum time. We allow for recording, and the minimum time we can store in the buffer. Will be recording for 5 seconds, but we allow for 6 seconds of recording for the sake of padding in case the application records 5.1 seconds or so. Okay. So lastly, we have set enumerations for different states in the program. First, the user can select a recording device. Then after the user selects a device, the user is stopped waiting to start. User is stopped waiting to start the recording. Okay. Then the user starts the recording for 5 seconds. After the user has finished recording, they can either start playback or record again. And if anything results in an error, it will go in an error state. Okay. Typically in these tutorials we go down the source code explaining what everything means along the way, but in this tutorial we're going to jump around more by flow of execution. It makes things easier to understand than just going down source code, so we don't get lost as we jump around the source file. Okay, so we have recording slash playback callbacks. Okay, we have recording slash playback callbacks. So I have a function audio recording callback, audio playback callback. We have sound audio recording playback. This is void user data and signed integer 8 stream, void user data, then 8, we have a stream and length. Though this should be size G length. Okay. Then we have sound audio playback. Okay, this was supposed to be callback. Audio playback callback. So same user data, stream and then I have a length. Okay. So these two callbacks are going to be doing the actual recording to and playing from our audio buffer. Okay. To details how these works. Okay. These are the functions that will actually record to and play from our audio buffer. Then we have okay. Then we create a texture. The texture, okay. So the text texture that specifies recording device names. Okay, so this is somewhat of a sound manager. Okay, so prompt texture. Okay, so for the sake of this, I'll just include texture.h here. Okay, then the text texture that specify recording device names. Okay, device texture, the number of available devices. This, okay. Received audio spec. Audio spec. Okay. So prompt texture. So I create texture. Prompt texture equals null. Then I have text textures that specify recording device names. Text textures that specify the recording devices names. So, we have an array of texture pointers. Device textures, and this is, I think, max recording devices, right? Yeah. Const expression, and says const expression. Okay, so max recording devices equals everything is null. Okay. Alright, so then we have okay, by definition this should be null. Everything in this should be null because this is a, yeah, explicitly setting it to null. Everything global is null. Okay, so everything global is null, so I don't need to do this. Okay. Then we have number of available devices. Or should I? Okay, just to be safe, let's just do that. Okay, we have number of available devices. Number of available devices. I have and recording device count. Okay, recording device count. Okay, I should, like, these are simple variables and these are container variables. I'll put the T, these are variables, but these are containers of some sort. Don't really work that way. Okay. Recording device count equals 0. And you have received audio spec. I don't know what that is. Received audio spec, STL audio spec, received recording spec, and okay, STL audio spec is received recording spec, and STL audio spec. This is received playback spec. Okay. Received playback spec. Alright, so here we have some textures. One to prompt, okay, one to prompt the texture to let them know what's going on, and another array of textures to show the names of the recording devices. We also have an integer to keep track of how many devices we have available. Okay, we also have two audio spec variables. An audio spec is an audio specification which basically defines how the audio is recorded. Okay, this basically defines how the audio will be recorded slash playback on this device. Feedback. When we open an audio device for recording or playing, we request a specification, but we may not get what we requested back because the audio driver does not support it. This is why we are going to store the specification we get from the driver for recording and playback. Okay, this specification is returned back by the audio driver and we will store it. Alright. Then we have a recording buffer. Okay, recording data buffer, size of data buffer, position in data buffer, and maximum position in data buffer for recording. Okay, recording. Okay, so we have recording data buffer. Recording data buffer. Recording buffer is null. Then we have size of data buffer. Size of data buffer. This is 32. Buffer byte size is 0. And we have position in data buffer. Which is buffer byte position 32. Buffer byte position is 0, I suppose. Then we have maximum position in data buffer for recording. Maximum position for data buffer in data buffer. Maximum position and data buffer for recording. So I prefer byte max position. Buffer byte max position is 0. Okay. The G recording buffer is a buffer of unsigned bytes that will store our audio data. Buffer byte size will store how many bytes the buffer will hold. Okay. Controls where we are in the buffer during recording or playback. Okay. So defines how much the buffer will store. Okay. And the byte max position controls the maximum piece of the buffer we will be using. Okay. If that's confusing, remember that G buffer byte size is 6 seconds for 6 seconds of bytes. Okay, 6 seconds of bytes, right? So we have 5 plus and buffer byte max position is 5 seconds of bytes we'll be using. Okay, so buffer byte size is 6 seconds of bytes. Okay, buffer byte size, so this will be equivalent of 6 seconds of bytes, 5 plus 1, and then max position This is the actual 5 seconds of bytes we will be using. Okay. Then we initialize audio and video. This is the main function. Run init. Okay. Audio and STL init audio. Okay. So we initialize the audio sub system 2. Okay. Make sure to initialize audio before recording or playback. It's an easy thing to forget. Right. So let me see that this compiles. Okay, this compiles, great. Well, okay, the last thing was okay. So now we have, okay, we open the font. Okay, then I define this starting point, revise. Get num audio devices, get capture device count, and if number of audio devices less than unable to get audio capture device. Okay. So yeah. Think recording device count. This is recording device count, right? Okay. So let me shift this thing here. Okay, so I don't think we will be counting frames. To be texture. Do I need timer? I think I will need timer at some point. So time text. Maybe I'll rename it to something else. Okay, destroy timer. Let's forget about this. Okay, so I have to destroy prompt texture and every device texture. Okay. So I'll first destroy prompt texture. And then I'll go prompt texture shift null, then point I equals 0, I less than, what is this? Max recording devices, right? Max recording devices, I plus plus, we go. If what is this called again? If okay, hold up, let me, yeah, okay, so recording devices, then this, what was this array called? This array is called device textures, device textures of eye. There you go. Texture destroy. Device textures of eye, and textures of eye equals no. Okay, great. So I've taken care of that. Alright, so next thing is we load up the texture. So I have this prompt texture which I need to load it up. Texture create. So prompt texture, line text. Okay, I load up the font. Loading font with 28 size, right. Handle the window events. We won't be needing any of these. Though here load media, load up the texture with prompt. So we have prompt texture in the font, and then I can okay, so I do need the text color. Right, so STL color. What just happened, my man? What did I do? Still color. Okay. Time text. Okay. Okay, still color and still text color. Still text color is all black. 00025. 25. Okay, so we load this function. The prompt is select your device recording devices. Select recording device. Right, select recording device. Then we get the capture device count. Okay. We get the device capture count. So I go recording device count. Recording device count equals stl get num audio devices and stl true. Okay. Fetching the available recording devices. Okay, then we check. I should be that this should be greater than. Okay, after loading the font and rendering the initial prompt message, okay, so I should render prompt texture. right? But it's not minimized. Update. Okay, there is nothing in update. So we have, okay, and then we check recording device count should be greater than 0, else we have a problem, which is unable to get audio capture device. Unable to get audio capture device, right? Then we go STL error, so STL get error. Okay, we have, after loading the font and rendering the initial prompt message, we get the number of available recording devices using the circle. When you pass an STL true argument, it will give us the number of recording devices. With STL false, it will get us playback devices. Okay. Okay. With STL true argument, we get the number of recording devices, and with STL false argument get the number of playback devices. Okay, if there isn't at least one recording device connected, we error out of the function. Okay, at least one device connected. Okay, so go cap recording device count, that if recording device count is greater than this, then recording device count is max, and then we have a prompt text. Okay, recording device count. Ooh. Okay, so let me prompt texture. Okay, let me compile this and see what happens. Ooh, counted frames. Yes. Where are the counted frames being updated? I believe it was here. Yeah. Okay. And everything else is FPS window render and function window render. Well, I have, there's only prompt. Oh, right. Prompt texture, then we have prompt texture. Okay. Okay, so I have not initialized any of the recording device textures. It's just created the prompt texture. Okay, prompt, it should be prompt texture and counted frames. Okay, max recording devices undeclared here. Huh, because I have not actually include this is sound.h. Okay, Great. Let me make it again. Okay, check FPS texture 98. There we go. We have prompt texture, and I think that is the only one. Okay, should display a little. Select recording devices. There we go. That's great. Okay. Time text. Okay, then we go check. Okay, at least one device connected. Okay. So if at least one device is connected, okay, so if at least one device is connected, then we cap the recording device count. Cap the recording device count. That is great, I'll only create as much as I need. Okay. So I'll check if recording device count is greater. If recording device count is greater than this is max recording devices. Greater than max recording devices. Then we say that recording device count equals max recording devices. Okay. Then we render the device name. Okay. Then we fetch the names of these devices and display them to be selected by the user. Okay. And type will be recording device count I plus plus. Okay. So we have a texture. Okay, prompt text. Have I created a prompt text? Prompt text. What is prompt text anywhere? And there we go. Prompt text is a string. Hold up a second. Okay, so we have a string, then okay. So I'll create a puff of 2 bytes again. That's the max we are going to go. Then I'll go as printf, right? As printf, I'll provide the buffer then I'll provide the format and then provide I. Right. Okay. So now I create a B string, right? Still get audio device name. It should return a char star, const char star. This is a CLTTF. Nope. Front page. STL2 over here. Then I go to functions and I want to find which one do I want to find? I want to find STL. Oh, right. Okay. So I didn't even have to. Okay, so it returned the const char star. Okay, great. That's what I'm expecting. So I have I, and then I create. So it's the string equivalent, the string version of I, for B string to be B string for concatenation string. I can create B string, right? Okay, lib.h. So we can create from a C string, or I can't. Okay, so I would have to create it from a C string, and then I can concatenate stuff onto it, right? So I'll go here, B string, let's say prompt text equals, this is B from CSTR, B from CSTR, and I provide the buffer I. Then we check prompt text should not be null. Failed to create string. Failed to create B string. Right, then I concatenate data to the text. Also I go, is this bcat the okay, so I have bcat CSTR, bcat CSTR from text comma this space, then this, right? Okay, then bcat CSTR prompt text comma then I want to concatenate this, right? STL get audio device name, STL get audio device name of I at value I, okay, and pass an STL true. Then create a text, create a texture from this, so first I'll go. What is this? What was the name of the array? The name of the array is device underscore textures. Okay. So go device underscore textures of I equals texture create. I hope I'm right. Right, okay. Okay, great. Texture create. Then we check device textures of I should not be null. Error failed to create the texture. Then I load up the texture with the font. Then I load it up with the font. So I'll go texture underscore load from rendered text. Okay, so load from rendered text, texture a window. Okay. So it takes in texture, which is device textures of I, a window. What else? Texture, window, font, then the text and the color. Okay. Texture, window, font, then the text itself, and then the color. Okay. I will be using so instead of creating it's okay. I'll just destroy the prompt text. Yeah, okay. So I can do this. Okay. Store the string version of okay. Convert I to string. And I can destroy it here. Then first I'll go with prompt text, then we destroy it, and then I'll go here b string prompt text equals null. Okay. Just put it here. Okay, contains the id and name of recording device. So we have recording device, then we put the value in this buffer. It's going to be 2 bytes. Then data. Okay. So we'll overwrite its value again and again. Ooh, so I feel like that this is just piling up. Yeah, okay. So I should destroy it after I'm done with it. So it won't create this variable again and again, right? It will just create it one time. I can refer to it just one time, and we destroy prompt text, and prompt text equals null. So yeah, man, it doesn't really matter that much now that I think about it. Create these variables. Okay. Deallocate the p string after its use. Okay, so we have load from render text this, right? Okay, if there are recording devices connected, we cap the number we use to 10, which may disappoint with those with 11 microphone vectors everything, and then go through devices rendering their names to a texture. We get the device name using get audio device and passing in the fact that we want recording device names with STL true and index of the recording device. Okay. Right. Okay. STL audio device ID. Okay, do the current state event handling. Okay, hold up. Let me prompt texture. Let me see the actual void close. Where is the render function? Updating playback. There is no texture render or recording. Then it goes. Nope, there is no actual render function. Okay, so that's easy, right? All right. So in fact, when I want to render, okay, so first we'll check if it compiles. We'll make, okay, CSTR, right. I cannot, my bad, I put I here, I have to put I buff. Okay, and that's all. Okay, directive argument in the range is print output between 2 and 12 bytes into a destination of size 2. Okay, directive writing between 1 and 11 bytes in the region of size 2. Oh, because int, yeah, my bad. Int, well, it would take, okay, I'll give it, let's say 4 bytes. Doesn't hurt. Okay. Okay. Directive writing between 1 and 11 bytes into a region of size 4. Format overflow. One and directive argument in the range. This output between 2 and 12 bytes in destination of 4. Again, actually I know that this value, I'm fine with that. Okay. Okay, select recording devices, and then okay, I wanna go to the render part. Screen width, let's say I want to center it, right? I want to center it on the screen. Width wise, center it on the screen, but height wise, I want to be screen height minus its height, don't half it. Or simple texture height. Okay, let me see what will this do. Right, there we go. Okay, render prompt on the screen. Okay, render the various device name based on the state. I'll check the state later, but I less than recording device count. You can get an actual reference. No? There we go, recording device count. Okay. I plus plus. Okay, so I'll have int y equals I want them all to have the same space, right? Okay, first right, okay, just multiples of this. So first we'll go with I plus 2, right? So I want to texture render and have device textures, if such as a thing, right? Device textures, device textures of I. Then I pass in the window. Then I pass in this thing. So screen width minus texture get width of device textures of I want to center it, divide it by 2, then I go y times I plus 2 and comma null x in y position, right? Okay. Alright, so we have microphone USB device and microphone streaming and microphone droid cam. Okay. This height, then this and this. Right, so these are the various devices. Okay. Okay, so it is in the leftmost. Huh. Well, okay. I can do that. I just have to push it to the left. Don't have to center it. Just push it to the left. Okay. Alright, so that's it for it now.